Hello students, I am Dr. Avnish Kumar Singh from Ambalika Institute of Management Technology, Lucknow, and here in this session we are going to discuss the module 3 quantum mechanics of subject physics, and our topic today is matter wave. Now, the outcome of this session, after studying this session, a student will able to understand the wave particle duality and its consequences, explain de Broglie hypothesis of matter wave, derive and apply the various expressions of de Broglie wavelength, explain the different properties of matter wave, and discuss the Bohr quantization rule and its analogy with de Broglie concept of matter wave. Now, first of all we have to understand what is a wave particle duality. If the wave and particle is indistinguishable, then we can say this is wave particle duality, but it is difficult to understand. First of all, how we can recognize someone? If in my class there is some student A is here, Sujit is here. Now, I can't when we first time meet Sujit, I do not know who is Sujit, then I meet Sujit one day, 2 day, I just relate some qualities, some characteristics of Sujit to his name, and then when we see him, I can easily say, hello Sujit, how are you? So, again there is a characteristics of wave and particle. If I ask you, this is the pen, okay, this is the wave or particle, you will simply say, sir, this is the particle. How you can say it? Because it has some mass, it has some space, it has some dimension, it has some size. Simply, this is the properties of particle. And what about the particle of wave? The energy, the amplitude, the frequency, the wavelength, these all are the property of wave. So, we can recognize the wave and particle with the help of these characteristics, one simple thing. Now, one thing which is well established before and we can discuss first, that is the wave and particle duality in wave, that is particle nature of wave. Actually, we can give the example of light, or we can understand simply this thing with the help of light. With the help of light we can see something, we can understand something where our eyes only work at the on the help of light, with the help of light. Now, light is wave or particle, always there is a contradiction between the scientist that light is wave or particle. In 1600, the two scientists who were just give the contradictory theories. One was the Christian Huygens and there was Isaac Newton. Christian Huygens told that wave is a light is a wave. He have told and he have described this thing with the help of different phenomena, the reflection and refraction, and he has shown that light just as a wave, it energy carry, it have some wavelength, it have some frequency. Whereas, Isaac Newton have told that light is the particle, and he have his own arguments that when the light hits some surface, it make it heat, it make it hot, like just a particle hit another particle, or he also show the reflection and different phenomena with the help of the wave light as a particle. But and we know that reputation of Isaac Newton was quite high at that time. So, his theory was in dominant position for a long time, but after some time when we talk about the different experiment, that was one slit and two slit experiment. One slit, that is the diffraction phenomena and interference phenomena, then polarization, various phenomena were seen, and then Maxwell come into the play, and he have given his four famous electromagnetic equation, that is Maxwell equation. He have derived a lot of things with the help of them, and those support the Huygens. And that time this theory was in a supersede position, But after again some time, we have studied in last class the black body radiation. Black body radiation was not results was not able to explain with the help of the classical theories. What were the classical theories? By taking energy, by taking the radiation as wave, that was only described with the help of by taking radiation as particle. So, black body radiation, photoelectric effect, Compton effect, all these experiment only can be explained by taking the light or energy or wave as wave packet, as particle nature. So, light have both the nature, that is particle nature as well as the wave nature, and that is well accepted. Now, the same argument with the particle, that is particle having some wave nature of particle. This phenomena first think by the various scientists, actually the science follow the symmetry, loves the symmetry, and if loves the symmetry, the wave which can behave like particle, why not particle behave like wave? But some boldness was required to discuss this thing, and Louis de Broglie, the scientist, in his work he has introduced this thing and discussed with Einstein. Einstein encouraged him, and finally he put his hypothesis on, and that was valid for the microscopic moving particle, and finally they behave like a diffraction of wave, and that was the famous experiment, that was Davison-Germer experiment. We are not going to study it actually, but the Davison-Germer experiment show the beam of electron, show the wave nature, that is diffraction of wave. So, a electron beam just hit a system and take the diffraction pattern, just like wave hit the system and give the diffraction pattern. So, wave particle duality, in short, quantum nature of light. When we talk about the quantum nature, we are talking about the particle nature of light. So, light is well understanding, wave, there is no problem in that, but there is other side of the coin, that is the particle. So, particle and wave are the both side of coins. Similarly, quantum nature of particle refers to wave attribute of particle. So, electromagnetic wave is said to display wave particle duality, that was well accepted before. I have told you it behaves like wave in one experiment, but as particle in other. As a person with schizophrenia, that means a person having dual nature, he behave like someone, he behave like king sometime, he behave like normally sometime. So, it is a problem with the mental or physical problem with the human being. Light just behave like this. We can understand moreover that when the light actually move, it behave wave nature, and when we hit light hit some surface, it generally behave particle nature. So, it depend upon the how the experiment was set up, how the measurement was taken. It the same light sometime behave like wave and sometime behave like particle. That is the wave particle duality in electromagnetic wave, that was well established. Now, de Broglie, Louis de Broglie, the scientist, he is a very bold person. First time he have introduced in 1923 in work that every moving particle always has a wave associated with it, just like photon is controlled by the wave. That wave is associated, moving particle is known as matter wave. Now, this is a different kind of wave, we do not compare it with the wave that is in the general wave. It is not general wave, it is different kind of wave, we will discuss later in detail what is the characteristics of matter wave, but a particle is somewhere here, a particle is, you can say again, a particle is somewhere here, and this is a region where there is a wave associated, this particle is moving, and there is a region around surrounding him, surrounding that particle, having a region, we can say this is the wave packet, and the matter wave is moving, and so this is the matter wave, this is the matter wave, the wave which is moving like this is the matter wave, and so having different velocity we will discuss later. And he have told again, just see, every moving particle always has a wave associated with it, just like photon is controlled by the wave. That wave associated with moving particle is known as matter wave. So, it is just like photon is controlled by the wave. So, he have told if photon is the part of wave energy can behave like particle. In similar way, a particle also can behave like a wave. So, whatever the condition is true for photon must be true for the this particle. So, here first of all established the relation, but the well established for the photon, that is energy of photon is given by E is equal to m c square is equal to h nu, and we can just replace the nu, that is S c upon lambda, and if we just ignore this, we have m c square is equal to S c upon lambda. So, c will be cancelled out, 1 c will be cancelled, m into c, the mass into speed, and that is momentum. So, p is equal to h upon lambda, that is equal to momentum is given by h upon lambda. He have converted this equation in terms of photon, clever thing. He have not used the expression of energy, because energy having some relativistic energy or some classical energy or so confusion there, but p is same for all. So, he have taken the expression of p, how it related with lambda. So, p is equal to h upon lambda, that was well true for the photon, and according to him the same equation must be true for particle. According to de Broglie, the same expression can be used for particle of mass m moving. When we talk about mass m, we are talking about the classical mass. That means, when we talk about the rest mass or m naught, that means we are discussing the relativistic situation, but we only talk about the mass m, we are talking about the classical situation, and there is no m naught. So, mass m moving with speed v. So, equation 1 can be written as lambda is equal to h upon p was the earlier equation, and p there we have converted m c is equal to p, but here we know that particle cannot move with the speed of light. So, for the particle we have to substitute h upon m into v. So, we have the formula, the same formula, that is for photon, but little different, that is p is equal to now m v. So, lambda is equal to h upon p, that is equal to h upon m v, the formula that is established by de Broglie for moving particle. And now this wavelength, remember this is now no more wavelength, this is known as now de Broglie wavelength. Do not call it wavelength, it is no more wavelength, because wavelength is belong to the wave, and here this is the de Broglie wavelength belong to the matter wave. So, there is no wave, there is a matter wave, there is no wavelength, there is de Broglie wavelength. So, we have to talk about the de Broglie wavelength of matter wave, and that is associated with moving particle. So, this is the famous formula that is given by de Broglie, lambda is equal to h upon p, that is same as h upon m v. Now, by replacing this p or v in various form well established formula, we can get the different expression for wavelength, and that is required for the numerical point of view in the examination, or the question can be asked in the examination that derive the de Broglie wavelength in terms of some temperature or kinetic energy, or for a particle, a charged particle of charge q moving velocity v, and some potential for potential accelerated by potential v. So, we can have a different kind of expression of this de Broglie wavelength. Let us see. Now, the de Broglie wavelength in terms of kinetic energy. Now, we are talking about the classical kinetic energy. Remember, consider a particle of mass m, again mass m, moving with speed v. Now, I am just writing here slow. Slow means this is v is very much less than c. That means, we are not talking about the relativistic case, we are talking about the classical case. So, having kinetic energy E k, So, E k is classical kinetic energy, we know the formula half m v square. If we multiply by m in denominator and numerator, we have m square v square upon m. So, m into v is equal to p. So, it is p square by 2 m, and that is p is equal to this whole thing go here, and we have under root 2 m e. Okay, is the subscript here. P is equal to under root 2 m e k, and we can put this value in equation number 1 or equation number 2, that was for the particle. Then we have lambda is equal to h upon p, instead of p we are going to put this value. So, it is h upon under root 2 m e k, that was the same de Broglie expression, wavelength expression in terms of kinetic energy. Next is the de Broglie wavelength in terms of temperature. Now, consider a particle of mass m at equilibrium. Equilibrium means the temperature direction is both side. This is not absorbing or just emitting after some time t, where capital T absolute temperature is constant. So, absolute temperature T. Remember one thing more, generally in physics we write the absolute temperature, that means temperature in Kelvin, and there is no hard and fast rule, but convention is that if we write the temperature T, that means we are talking about temperature in centigrade, but here we are mostly talking about the temperature T, that is absolute temperature, that is in Kelvin. Then its kinetic energy, this well established formula, again we know this formula, E k is equal to 3 by 2 k T. Here k is the Boltzmann constant, and we can directly put this value in equation number 3, or you can put here p square by 2 m. We can evaluate the value of p and go to the equation number 2. So, we can use equation number 2 and also equation number 3, depend upon we are using directly value of E k or we are evaluating the value of p and then putting in equation number 2. So, we have h upon lambda is equal to h upon under root 2 m E k, using this value E k here is equal to h upon under root 2 m 3 by 2 k T. 2 will be cancelled out, and finally, we have lambda is equal to h upon under root 3 m k T. So, now here lambda is the function of temperature, earlier lambda was the function of kinetic energy. So, we have the same de Broglie wavelength in terms of various parameters. Again the de Broglie wavelength in terms of higher speed. The formula we have lambda is equal to h upon m v, but do not be confused in examination where you have given v and you do not if see the value of v and just use the value, that is formula lambda is equal to h upon v, things can become wrong there. We have to see that what is the value. If the value of velocity is of the order of 10 to power 8, that it is more than 3.14 into power 7 meter per second or more, then we have to use this formula only, that we have to replace the mass by this relativistic mass, then its relativistic mass, this is the formula you have studied in module number 1, that relativistic mass is given by m is equal to m naught upon under root 1 minus v square by c square. You know the 1 upon under root 1 minus v square by c square is the relativistic factor. M naught is the rest mass. So, we have here talk about the rest mass. The rest mass is actually the mass of the body corresponding to v is equal to 0, mass of the body at rest. So, by using equation 2, that equation 2 was lambda is equal to h upon m v. We have just put the value of m here in terms of m naught, we have h upon m naught multiply by under root 1 minus v square by c square. So, this is the presentation, this is the formula for de Broglie wavelength only for the particles which are moving with the speed that is corresponding to the speed of light. Now, the de Broglie wavelength for the charged particle, very interesting charged particle, and if there is a charged particle of charge q or charge E you can say, and moving with some because of some acceleration due to potential V, then kinetic energy is given by QV. And now simply we can again replace equation number 3 you can say, or you can use the P square by 2m. So, you can use equation number 2. So, you can use either equation number 3 directly, or you can just evaluate the value of P and use equation number 2, and you can just put value E k, and so lambda is equal to h upon under root 2 m E k is equal to h upon under root 2 m q v. So, the lambda is the function of q and v. Lambda is equal to h upon under root 2 m q v. Now, again the same formula, but sometimes this we have lot of question that is only belong to the electron. So, the same formula, but for the electron, and that is accelerated by potential V. So, the formula is same, we have m e, that is m naught actually, the charge is q, that is equal to E. We know for electron both are the constant m e and E. If you put the constant value 9.1 10 to power minus 31, 1.6 10 to power minus 19, and the constant h we know already. We solve it, we have the value lambda is equal to 12.28 upon under root V in angstrom, remember angstrom. In all other formula, when we calculate the lambda, we have the value in terms of meter, but here we have just modified this equation in terms of angstrom. So, this is a simple ready made formula. If we know the potential V by which a electron is accelerated, then we can use this formula, but the result in angstrom, just remember it, do not be confused. Again the question come for the alpha particle, many times alpha particle. So, we must know what is the alpha particle. Now, alpha particle is the, if charged particle is alpha particle. Now, alpha particle is the nucleus of helium, that is having, you can say having 2 protons and you can say 2 neutrons, 2 protons and 2 neutrons, and if it the mass that is 4 times of neutron, or because mass of neutron and proton is almost same. So, mass of alpha particle is equal to 4 times of mass of proton or mass of neutron, and charge on this neutron charge is 0 and only the charge on the proton, that is 2 protons. So, positive 2 E is the charge on electron, but negative sign, here the charge is positive. So, we have to just put this value. So, there is no difference in this particular formula, but we have to just remember what is the alpha particle, and accordingly we have put the value of mass of alpha particle and charge of alpha particle. Here Mn and Mp are the mass of neutron and proton respectively, and E is the charge on proton. Now, from equation 6 we have lambda is equal to h upon under root 2 m alpha q alpha v. So, the de Broglie wavelength for the alpha particle, lambda is equal to h upon under root 2 into 4 mp into 2 e into v, and by solving it we have h upon under root 16 mp ev. We can solve further, but it is just for you have to remember what is alpha particle. This is the famous question that is coming in examination for the alpha particle. So, you must know the what is alpha particle, accordingly you can change the formula. So, we have a different expression of lambda in terms of kinetic energy, velocity, that is high velocity, the temperature, the charge particle that is accelerated by potential V. So, we can use that particular formula according to the given data for the numerical or whatever the question asks for in the examination. So, there is some numerical problem. It is not only the numerical problem, it is a very interesting numerical problem to understand what is going on here. Find the de Broglie wavelength, 2 questions. One, 46 gram of golf ball moving with a velocity of 30 meter per second, and second part of this question is an electron moving in velocity 10 to power 6 meter per second. First of all, both the velocities are classical, 30 meter per second and 10 to power 6. It is looking much more, but it is again a classical one. So, we have the formula see V is very much less than sen, though m is equal to m naught. So, there is no do not try to use that formula for relativistic mass. Lambda is equal to h upon mv. So, m is equal to 46 gram, we can convert into kg, and lambda is h upon mv. We can solve this will be 4.8 into 10 to power minus 34 meter. Just see this value, just concentrate on this value. This value is very small in dimension compared to the golf ball. That means, for macroscopic particle it is very difficult to understand. The wavelength associated with golf particle is so small compared to dimension that we would not expect to find any wave aspect in this behavior. And when we talk about the electron, the value is 7.3 10 to power minus 10, and this is quite close to the dimension where the electron reside. Dimension of atom is comparable with the value. Therefore, moving electrons show the wave character, which is key to understanding atomic structure and behavior. Now, the very important part, that is property of matter wave. There is few properties of matter wave. One, lambda is directly proportional to 1 upon m. Lighter the particle, greater the wavelength associated with it, and we can only observe, only measure the wavelength when wavelength is greater, when wavelength is observable. If the wavelength is very small, we cannot observe it. So, for a lighter particle only the wavelength can be seen. Again the same formula, lambda is equal to h upon mv. So, we have lambda is directly proportional to 1 upon v. Smaller the velocity of the particle, greater the wavelength associated with it. So, we have two conditions, m should be light and v should be small, then only lambda is observable. Other very interesting thing, we have lambda is equal to h upon v. So, for v is equal to 0, we have lambda is equal to infinite, or for v is equal to infinite, we have lambda is equal to 0. There is no meaning of lambda is equal to infinite or lambda is equal to 0. That means, there is no meaning of the de Broglie wavelength for v is equal to 0 or v is equal to infinite. That means, the matter wave is only associated with the finite motion of particle. Do not think if a particle is moving very fast, then matter wave is doing something special. No, it is only legal, it is only doing for the finite velocity. The matter wave is independent. Now, next two parts are the, if you want to distinguish the matter wave with electromagnetic wave, we can understand this. Matter wave is independent of charge of the material particle. It means matter wave of the de Broglie wave is associated with every moving particle, whether charged or uncharged. That is the actual difference between the matter wave and electromagnetic wave. When a particle is moving, then if charged particle is moving, electromagnetic wave comes out, but here particle charged or uncharged, there is a matter wave. Velocity of the matter wave depend upon the velocity of materialistic particle. Again, it is the difference of the electromagnetic wave, it is not constant. When you talk about the electromagnetic wave, it is constant, it is c, but here it depend upon the material particle velocity. Now, matter wave represent the probability of finding a particle in space. I have told you there is a wave packet, and there is some every time the particle is inside this volume, and there is a probability of finding the particle in this volume. Matter wave can propagate in vacuum, hence they are not mechanical wave. Now, the phase velocity of matter wave can be greater than the speed of light. That is surprising, and we can just simply by using this formula, omega is equal to nu lambda, where omega is the phase velocity. Now, energy is equal to h nu is equal to m c square, and nu is equal to m c square by h, and by using the de Broglie hypothesis, we have lambda is equal to h upon m v, and if you put the value of and nu and lambda by omega is equal to m c square by h, here nu, and putting the value of lambda h upon m v, we have m will cancel out and we have h cancel out, and we have c square by v. So, omega is equal to c square by v, where v is very much less than c. So, omega is greater than c, that is the result we have to understand. So, it is not a physical wave. If a velocity cannot be greater than velocity of light, but theoretically for the matter wave it can be greater than the velocity of light, since matter wave velocity may be greater than c. So, it is clear that matter wave are not the physical wave. Now, the de Broglie hypothesis and Bohr quantization rule, very simple, just try to understand. This question come in the section A, very small question. De Broglie suggests that stationary orbit are those in which orbital circumference 2 pi r is an integral multiple of de Broglie wavelength lambda. So, if this is the orbit, then it is the electron will be only this orbit when there is a standing wave is formed, that is 2 pi r is equal to integral multiple of lambda, 2 pi r is equal to n lambda, and de Broglie wavelength that is given by h upon p, that is h upon mv. So, if you put the value of lambda here, 2 pi r is equal to nh upon mv, or mvr is equal to nh upon 2 pi. Now, this formula is the Bohr quantization rule, and that is actually the consequence of de Broglie hypothesis here. So, de Broglie concept confirm that the quantization of angular momentum is the direct consequence of wave nature of electron. Okay. Thank you.